Hey, what's up, Morpheus? Welcome back to the Code Cartel. And this will be a masterclass into a dependency injection, and you will know everything that you need to know about dependency injection in general. And the two rules that you need to keep in mind while watching this course. The first one is that you take notes. That's the first rule. Second rule: you build something after I built it. Okay, when I'm building something, when I'm writing some code, you first watch it, you understand it, and after you have understood it, only then build something. Okay, it will be a good introduction for anyone into dependency injection. You don't have to watch anything after this. Let's get started with some kind of definition here. So dependency injection is a part of Android architecture. Okay, we use dependency injection in our Android architecture. Okay, it promotes the following: reusability of the code, ease of refactoring, and ease of testing. A lot of things that DI helps us with. Reusability of code, ease of refactoring, and ease of testing are the main advantages of DI. And we will be looking at these advantages and how DI is helping in this. Another important thing that you need to keep in mind is that whenever an interviewer asks you, why do we even need dependency injection? You need to answer these: reusability of code, ease of refactoring, and ease of testing. An interviewer will always ask you when it comes to the basics, like SD1 interview question would be there, and he will always ask you, why do we need DI? Okay, can't we do manual injection or something like that? This will be the reason, this will be the answer to that thing. That, for example, when you're using Dagger Hilt, why are we using Dagger Hilt? These will be the answer: reusability of code, ease of refactoring, ease of testing. And of course, there are more advantages to it, but we'll be seeing them afterwards. But this is the basic stuff that you need to keep in mind. You can note it down for now. Let's go further and actually understand what is dependency injection. Okay, actually, dependency injection DI can be broken down into two words, which is dependency and injection. Let's first understand what is dependency. The classes often require instances of other classes to function properly, and that is what we call dependency. Okay, if you do not understand what I'm saying, let me give you an example. Let's just say there is a car class, right? Now this is a car class, and this car class, in order to function properly, needs some kind of engine, right? Maybe brakes here. So all of these things are different classes. So this is an engine class, brake class, gear class. So car class is dependent on these classes to function properly. Car class requires the instance of engine class to function properly, and that is the reason the car class is dependent on engine, and engine is the dependency that a car class requires. That is the simple introduction into dependency. Okay, now what is injection? So what is injection? First of all, the references required are called dependencies. The engine dependency is required by the car class to function properly. When we insert the instance of the required class, which is the engine class, into the class that requires it, for example, the car class, then it becomes the injection. And together, when we insert the instance, now instance is what, and together that becomes dependency injection. The instance is basically the dependency, and when we are inserting into the class that requires it, that becomes dependency injection. It is simple as that. Okay, that is what dependency injection simply means. Okay, now dependency injection in terms is a design pattern, and it follows a certain criteria in how to basically, dependency injection is basically a design pattern that allows us to insert the dependencies into the class that requires it in a particular pattern, and that is what we call dependency injection in general. So dependency injection just simply means injecting dependencies into the class that requires it. Okay, and we follow a certain pattern to inject these dependencies, and that is called dependency injection design pattern. Okay, it's simple as that. Okay, hopefully this gives you a very good idea into the basics of dependency injection. Let's get started, and so let's explore more. Now there are other ways to get the dependency ins that we want. There's some ways. Now there are three ways to get the dependencies that we want. Create their own. Okay, now classes can create their own dependency. For example, a class can just create and initialize an engine dependency, an engine instance, into the car class itself, and so the car class creates its own dependency and it gets inserted into it. Okay, use some form of an API. For example, there are some APIs in Android, for example, that we can access from .context at get system service, something like that. So there might be some kind of API that Android exposes, and we get the dependency from there. Or dependency injected as parameters. That is what we call DI. The design dependency injection design pattern is this particular thing. Dependency injections as parameters. Okay, dependencies injected as parameters. That is what we call dependency injection design pattern, and that is what we are going to discuss about. Let's look at each one of these and try to understand what is the difference, what is happening, and it will give you a very good idea. Now let's take a look at the example of dependency. Okay, now let's take a look at how classes can create their own dependency. Okay, let's take a look. This is an example of a car class, right? The car class class makes its own engine dependency right here. And then there's a function start, and engine.start is called. And this is an instance of the car class, and the car.start function is called. Okay, now what is happening right here is that this car class creates its own engine dependency right here. And you can see the thing is that it is not being injected. It is not some kind of API, but instance of the engine class is being initialized into the car class itself, and then we can use this instance right here. And that is how the dependency injection that is how the car class can create its own dependency injection. Now there are certain problems, there's certain issues with this particular approach. Let's look at them first of all. Now, what are the issues with this thing? First of all, the car is creating this dependency every single time the car is initialized. Okay, now this thing might be that we need to create this dependency every single time the car is initialized. Okay, and the thing is, with like if there are two to three different cars, there'll be 2 to 3 different engines as well. So every car class have a different instance of engine class. Okay, that might not be a problem in the long. That might not be a problem. Now there's some issues with this kind of approach. Okay, what is happening is that you are creating a dependency right here, an instance of a class right here inside of the class right here. Right, now every time the car class is created, we have to create this dependency as well. Okay, this instance is automatically created when the car class is created. Okay, and with every car class initialization, there is a different instance of engine created. Okay, so there are too many differences, there are too many engines being created, there are too many instances of cars, too many instances of car class and engine class being created. Okay, that is one big thing. There are too many instances and objects being created together, and that could be a problem in the longer run. Another problem is that when it comes to engine, this thing is not being provided through a parameter, which means that first of all, we do not know what the car class actually requires. So let's try to actually block everything right here. Let's just say that we blocked everything right here. We do not know what a car class has. Now the car we just initialize and just start it. Right, it seems simplistic, but the thing is that if we do some kind of change to the instance of the engine right here, what will happen is we do not know that the car class is actually dependent on it, and the changes to the engine might affect the car class as well, right? And this will cause a problem in the longer run. We do not know what is happening inside of the car class, right? And that is some kind of problem that might arise in the future. Another problem is that if you want to test this class, for example, if we want to mock the engine class, right, and provide it to car class, we cannot do so, because every time the car class is initializing, it actually uses the actual engine class. And if you want to mock this engine class, we cannot do so, right? If you want to make a fake engine, let's just say that we make a fake engine class, right? And if you want to use this, we would have to actually change the implementation of this car class, right? If you don't want to use the actual engine class for testing, you want to use the fake engine class, you would have to change the implementation of the car class, and that is a big problem. We cannot test this class because they are very tightly coupled. Okay, so these were some of the problems and issues that might arise in the longer run, and we'll go through the projects and try to see what is happening, and it will actually give you a very good idea of why this is wrong. Okay, so you can of course note this thing down, and this will be a good example of a class creating its own dependency. Okay, so use for some form of API. We already know that we can use some kind of Android API to get the instance or get some kind of dependency that we want. Let's just look at some kind of Android. As you can see, this is like a location manager that we can get from Get System Service. This is again an API that we can use from Android and get the location manager. I think this is there, right? So these are all examples of APIs from Android being exposed right here. Okay. Now this is the example of API, and let's look at dependency injections injected as parameters. Okay, now this is the example. Now this is the example of dependency injection, right? Which is that the dependencies are injected as parameter. Okay, now what is happening is that the engine dependency right here is being injected through the constructor class. Okay, constructor of the car class, right? Private val engine is injected right here, and then we can use the engine instance right here to start it, and we can can call the start function wherever we want. Okay, makes sense. Now let's take a look at how we are injecting this thing. We first initialize the engine instance right here, then we give it inside of a parameter right here inside of the car class, and then you can call whatever the function we want, and that is simply dependency injection. This is called manual dependency injection. We'll be looking at automatic dependency injection as well, and that is done through Dagger Hilt, Dagger, stuff like that. So we'll be looking at that. And what is happening, what are the advantages of this approach is that now if you want to make a fake engine class and inject it right here, let's just fake engine class, like fake engine, let's call it, yeah, whatever the class is saying, we are basically inheriting from an engine class, and then we can replace this fake engine from the instance of the engine class, and this fake engine has its own implementation basically faking actual engine class, and then we can actually test it, and that becomes testable. One advantage is of course that we can easily test this class. Another advantage is that now the car class is being initialized. It doesn't have to actually initialize the engine class again and again, right? Now that is done through the parameters. Okay, and the thing is that the engine class might be a singleton, right? And we can have this engine class being injected every time here, but the instance remains the same. Okay, it's simple as that, and that is powerful. That is basically what dependency injection is. So these were the ways to actually get the dependencies that we want. I hope it gave you a very good introduction into dependency injection in general. Let's look further and try to actually understand the definition of dependency injection. So dependency injection design pattern basically suggests that the dependency injection so what is dependency injection? Dependency injection is a design pattern where objects receive their dependencies, other objects they need to function, from an external source rather than creating them internally. As we've already looked at an example where the car class was creating its own engine dependency, that is not the part of dependency injection. But when we pass the dependency through the parameter and it comes from an external source, then it is called dependency injection. As simple as that. Okay, so rather than creating it internally, right? Rather than creating them internally, the objects receive their dependencies. The other objects they need to function from external source. That is called the design pattern dependency injection. It's simple as that. Hopefully this makes it pretty clear to you. Now let's take a look at a class actually following dependency injection and a class that does not follow dependency injection, and try to see what are the advantages of dependency injection in general. Okay, let's try to look at the class that does not follow first. Okay, there were some problems, as I've already told. It's hard to test this particular class because you cannot fake the engine class right here. Another thing is every time the car class is initialized, engine class is also initialized. I think so it is also breaking some of the solid principles. Another thing is that if we want to extend the car class, let's just say that we want to make electric car, not the petrol car or diesel. Now the electric car does not have an engine. It might have a motor class, right? And if you want a motor class here and it is a type of a car, we cannot actually extend it. Every time the car class is created, the engine class is also created, and that engine class is also present inside of electric car, and we don't need that. So again, it breaks some principles that we are following. Like we cannot inherit the car class properly. It initializes some of the instances that we don't actually need. So the main issue would be that the car class is not scalable enough. If we want to make a vehicle class and the vehicle class has an engine class, a car might require an engine, a car might require a motor, the bike class would be different when it comes to vehicle, a truck class would be different when it comes to vehicle. So we have to keep in mind that what kind of dependencies a class might need, and is it scalable or not. That is the thing about the car class. It is not scalable when it comes to hard coding the instances inside of the car class. Now let's take a look at dependency injection pattern. What happens here? Again, this is good that through dependency injection, this car class becomes testable. We can just mock the engine class where we want. Another thing is that if we extend the car class, we can make an electric car, and this becomes scalable. We don't actually have to give it an engine type every time we want to. Okay, and that becomes scalable, right? So these are some of the advantages. Now we've already looked at some of the advantages of DI, which is the reusability of code, ease of testing, ease of refactoring, right? Okay, let me quickly actually list them down. First of all, easily testable. One of the major advantages that we can actually mock the class and actually test it. It is scalable. And another thing is not creating unnecessary instances. There's no tight coupling here. There's no tight coupling here, and also the thing is that it follows solid principles that the class solid principle, the first rule, there says that the class should have only one responsibility. So this class has only one responsibility of the car. Okay. Now when it comes to this thing, this car class has two responsibility. First, to actually create the engine and then use it into the functionality of the car class. So this breaks the solid principle S in the single responsibility principle right here. And again, that is a problem. So these are some of the advantages of DI, and we have also looked at the example and a very good definition. Hopefully this makes it pretty clear to you what dependency injection is. We have already looked at examples and some of the advantages that we have right here. Now there are actually two ways to do the dependency injection. The first one is called constructor injection and another is called field injection. Now constructor injection, we have already seen an example of this, which is passing dependency through a constructor, right? A car class has a constructor and we pass the engine class through that constructor and that becomes the constructor injection. The field injection, dependencies are created after the classes are created, used in cases where DI cannot be injected with the constructor. Example, activity of fragments. We cannot use the activities constructor fragments constructor to actually pass the dependencies. So we just use field injection there. We will look at the example of this and this as well. Now let's take a look at the examples of dependency injection, the two types of dependency injection. Now this is constructor injection, this is constructor injection, this is field injection. Okay, let's take a look at constructor injection first. Okay, now what is happening inside of a constructor injection is simply the instance of the engine is being injected to the constructor of the car class right here. The instance is created, injected into the constructor, and then the instance is used whenever the function is being called right here. Simple as that. So the constructor is being used to inject everything. Okay, and this is called constructor inject. Most of the DI will be done through constructor injection. In some of the cases, we will be using the field injection. Now what is field injection? As you can see, we create a late init variable right here to initialize the engine class later on. Now what do you mean by later on initialization? It means whenever the car class has been created, only then we initialize the engine class, right? That is the rule of field injection. Okay, now let's take an example right here where while car class, now the car instance is created first, then engine instance is created and assigned to the car class right here, as you can see, and then the car start function is called, right? But this engine instance is given to this late init variable, and this late init variable can be used inside of the start function right here, and that is what is called right here, right? This makes sense. This is called field injection. Now this happens in case of activities or fragments because we cannot just use their constructor to pass the values, right? Here it's a simple class, we can actually pass it to the constructor, but when it comes to activity and fragments, this is the way to do a dependency injection. Most of the activities and fragments that we'll be injecting in, this is the way to do field injection there, and we'll be looking at projects where the dependency injection is done, and that is how we do the field injection in general. Hopefully this makes it pretty clear to you what is dependency injection. You can actually pretty much note this down, and this will give you a very good idea. Constructor injection, field injection, what is DI, we have already learned a lot of the basics right here. Let's learn some more. So let's explore some further. Now there are actually two ways to do dependency injection. Now one is an automated DI and another one is manual DI. When we create dependencies manually, then it is called manual injection. If we try to create it with automation, then it will be called automatic injection. And we use different libraries for automatic DI, which is Dagger Hilt and Dagger. Now what is manual injection? We have already seen this in our example. This is the example of manual injection. As you can see, we are manually creating the engine class and injecting it. But the example, this is the example of manual injection in general. Okay. Now, if you want to actually do automation, then we have to use Dagger, Hilt and Dagger. We'll of course look at that, but first we'll try to understand how to do manual DI, because that is the basics of how Dagger Hilt works inside. Okay, that is the basics that Dagger Hilt uses to actually do automatic DI. Okay. You look at the examples, we look at everything that you need to know. Now, inside of the automatic injection right here, there actually are two ways to do dependency injection again. The one is called a reflection-based solution that connects the dependencies at a runtime. Okay, another is static solution that generates the code to connect the dependency at the compile time. And this is what we are using when it comes to Dagger Hilt and Dagger. Okay, so this is the good approach, and that is what we are using nowadays, not the reflection based solutions anymore. Okay, this was some of the basic stuff around AI. You can of course note these things down, and this will give you a very good foundation before understanding Dagger Hilt and Dagger. Now there's an alternative to dependency injection pattern called the service locator pattern. So what is this service locator pattern? Service locator pattern allows classes to ask for the dependencies to be injected. Okay, that's the thing, that in the dependency injection, we create the instances and inject it into the classes. But in case of service locator pattern, the classes ask for the dependencies and inject into themselves. Okay, now that is the difference between these two patterns. Okay, this is the overview of what is the difference between these. Okay, now the DI pattern allows the app to control the dependencies and inject the required dependency. So dependency injection pattern is where we create the dependencies and we inject them. We control the dependencies, not the class itself, and that is the part of DI. Okay, and that's why DI is preferred over service locator. You look at it, what is the difference between these two and why one is preferred and why one isn't. Okay, now why is service locator pattern not that great? Okay, the collection of dependencies in service locator pattern make it harder to test because every dependency is inside of a single global class. Okay, now what do you mean by is inside of a single global class? What happens is, if you have used Coin, we create a single class, right? This class is responsible for every single dependency inside of our app. And the thing is, we have to first create the dependency that all of these things require. That we have to create the dependencies by line. It means that, for example, this class requires this dependency. Then this dependency has to be up before this dependency. Okay. If this class requires this dependencies, then it has to be up here before this one. So every single dependency is prioritized basis on which class requires which one. Okay. And it is all inside of a one global class. So it becomes really hard to test. Now actually look at this example. Okay, now what is happening here is that this is a user repository right here, right? And it has two kind of dependencies right here, which is by inject API service, user DAO, database, and some kind of API service. Okay, now this is happening we are using Coin to do this. Coin uses service locator pattern. Okay, this is a suspend function. This is view model. Okay, now it requires again some kind of dependency. Now testing problem with the locator. Okay, this is the testing rule. Okay, this is what happens when we look into the module of the now this is the module of the Coin. It means that first we need to create a single dependency of API service, then we create a dependency of user DAO, then we create a user repository, and all of these dependencies are passed right here inside of a repository. Can't pass the mocks directly because the inject is present right here, right? That is the problem with service locator pattern, right? This is that the class is getting all of its dependencies directly. It is not done through DI, through constructor injection, and that is causing a problem. Here you can see dependencies are hidden, can't see what user repository needs, must configure mocks in global Coin container. Okay, as you can see. So again, there are some of the problems with service locator pattern in general. That's why we don't use it. First one is, of course, that it creates a global class, and that is a big problem, that every dependency is inside of this global class, and if you want to mock it, it becomes very difficult to do so. The dependency implementation is inside of the class, so it is hard to know what a class might require. So changes to a class or service locator might result in failure, as you've seen already in this kind of thing. This user repository is not taking dependencies from a constructor. We do not know what is happening inside of the user repository. We cannot just simply mock any dependency and provide to it. We need to know what kind of dependency the user repository requires, and that is causing the problem here, that we do not actually know the dependencies required by the user repository. The dependency implementation is inside the class, so it's hard to know what a class might require. Any changes to the class or a service locator might result in failure. Managing lifetime objects is difficult. If you want to scope object to a particular scope, usually lifetime is tied to the lifecycle of the application. Now, when we create this global class, usually what happens is every single dependency is tied to the lifecycle of the application itself. And it becomes difficult to actually scope one single dependency to just, let's just say, one activity. And that is why it is not preferred to use service locator pattern. These are some of the disadvantages, some of the things that's why dependency injection is preferred over service locator pattern. And yeah, Coin is the part of service locator pattern. Dependency injection is done with Dagger Hilt and Dagger. Now let's take a look at manual dependency injection. Now what is happening here? We manually create and manage all of the dependency without using any library. That is called manual injection. And it basically means that we would have to create dependencies of every class in a flow. Now what do I mean by that? We have already seen what is manual injection and automation injection. You just manually create them and use the dependencies. And it basically means that we have to create dependencies of every class in a flow. Now what does this particular thing mean? Let's take an example here. Okay, we have seen this kind of flow before. Here is simply an activity dependent upon a view model, dependent upon a repository, which is dependent upon the remote data source and local data source, and it is dependent on SQLite and some kind of web service. Now this is basically what a usual flow of an app looks like, right? The activity is your UI, view model is the business logic, repository is talking to the model, and remote data source gathering all of the data that is related to maybe the database or the API. That is what is happening inside of the activity, right? And that is the source, and that gets present into the activity itself. Okay, now let's take a look at, let's just say that if we want to create the dependency of user repository or user view model, let's take an example of user view model. If you want to create a dependency of the user view model, we would need the dependency of repository. The repository would need a dependency of the model and remote data source, right? So all of these dependencies are present in the flow. First we create the dependencies of the model, then we create the dependency of the repository, then we create the dependency of the view model, then it is passed to the activity if that's what we are looking for, right? And that's the thing. Let's look at this particular graph again. Right. Now this is a graph that says that login activity is dependent upon login view model. Login view model is dependent upon user repository. User repository is dependent upon user local data source and user remote data source. User remote data source is dependent upon the dependency of the retrofit. And that is the usual flow of our app. Let's try to create this here. Okay. Let's expand this and let's try to understand it. Okay, now we are creating the dependency of login view model inside of an activity. Let's zoom in here. What is happening here? Now in onCreate, what we do, in order to satisfy the dependencies of login view model, you have to also satisfy the dependencies of all of its dependency recursively. First, we create retrofit, which is the dependency of user remote data source. As you've already seen, we need retrofit first. Then only we can create a user remote data source. Okay, we build the retrofit right here. Okay, with a login service here, and we create a remote data source and pass the retrofit. We create a local data source and initialize it right here. Then we are able to create the user repository. User repository requires a local data source and a remote data source. And then only then we create the login view model. So as you can see, all of the dependencies need to be created inside in a flow in order to do this kind of manual injection. Okay, I hope this makes sense. If you want to note this down, you can. This is the flow and everything that you want to know. Now we've already seen what is happening inside of a manual injection, right? But there are certain problems with manual injection. Okay, the first problem is there is a lot of boilerplate code. As you've seen in this, again, if we want to create a simple login view model, a lot of things need to be created first. Only then we are able to create this login view model. And if you want to create it somewhere else, we have to create it, write all the dependencies again from zero. Now that is a lot of boilerplate code. And if we want to create a login view model instance again, then we'll have to create all of the dependencies again. That is a problem. Dependencies have to be declared in an order. It means that if there are a lot more things that are dependent upon each other, and even if they are not dependent upon each other, we by mistake create something before then the other thing, then it would cause the dependencies to fail and the class will not function properly. And that is a big flaw when it comes to creating dependencies in a flow. It is difficult to reuse the objects. If you want to reuse the objects, then we would have to follow singleton pattern. Singleton pattern is hard to test. Okay, what we want to do is when we create this kind of dependencies, and for example in the retrofit, we create a singleton pattern and create a retrofit, right? But then this particular singleton becomes really hard to test. Okay, singletons are hard to test in general, and we will look at why singleton is hard to test. There's a lot of examples, but this is one of the flaws in manual injection, that if we want to reuse objects, it becomes hard to test. That's why we don't use singleton. Okay, and all of this is encountered very easily in our automated dependency injection using Daggerhill. We will look at it with an example, and it will be much clearer to you. Hopefully, you guys really enjoyed this session, and if you did, you know what to do. Like, share, subscribe, and of course, I'll catch you next time. Bye bye.